I'm going to briefly introduce myself and then bring the panel onto the stage. My name is Dave Rosendahl. I'm the president here at a company called Mindfire, and my company has had a long relationship specifically with the print industry in both 2D and 3D printing. And through those interactions, I've become somewhat of an industry connector, bringing folks together like the panel that we have here today. In fact, it's because of that that Kevin Carr, who I'm bringing to the virtual stage next, asked us for our help in producing this event for you today. In case you don't know Kevin, he's president of Master Graphics, where for over 70 years, they've sold wide format and graphics printers. Kevin, you look fantastic for being over 70 years old, by the way. I just got to tell you.
Yes.
They've also expanded to offer 3D printers from HP, 3D Systems, 3D Platform, and more. And their focus as an organization is to partner with manufacturers to successfully implement additive manufacturing. And something that's great about Kevin, and again, which is the reason why we're here together, is Kevin is passionate about bringing the 3D print community together to learn, to get inspired, and to take action through events like the one we have today. Kevin, welcome. How are you this morning?
Yeah, great, David. And again, thanks for having us. And we're working on our video, so we'll have that soon. But yeah, thank you once again for hosting. And of course, everyone joining us in our expert panel. You know, I love this. This is, I think, our 4th or 5th webinar we're doing together. And it's always been informative. So again, thank you everyone for joining, and thank you for hosting once again.
Absolutely. My team, if you could drop Kevin's LinkedIn URL there into the chat, folks, make sure to connect with him after the event so that you can stay connected with him. Next up is Carl Douglas. He's on the panel today as well. He's the CEO of DI Labs. Carl is a licensed professional engineer with over 20 years of experience. He's got a mechanical engineering degree from Ohio Northern University and an MBA from the U of M Carlson School of Business. His focus is helping companies overcome roadblocks and discover innovative opportunities using additive manufacturing technologies. And he supports projects through the entirety of the product lifecycle, something we're going to be talking about today, that being from prototyping all the way to high volume production. Carl, thanks for being here with us today. How are you?
I'm real well. Thank you, David. It's great to be here with Kevin and Brian, and looking forward to the conversation.
Fantastic. Thank you for being here as well. We look forward to your insights in the panel. And lastly, meet David Tucker. No, I'm just kidding. Not really. David was whisked away to MIT today. And so in his stead, we have a special guest. We've got Brian. Brian here on the screen. As you can see, Brian Douglas attended Colorado State University, where he studied mechanical engineering, and he's now the CEO of DI Labs. So David was supposed to be here with us today, but had something come up at MIT. And so, Brian, we appreciate you being here with us. I know that at DI Labs, you're bringing 15 years of experience as an inventor, and that you've got hands-on experience with precision electronic mechanical design, diagnostics, and repair. Like I said, thank you for being here on such short notice. How are you this morning? Or I guess for you, it's almost midday.
Doing well here. Appreciate the opportunity to talk about this with you all. And of course, changes like this, it's a part of our everyday, so we're ready for it.
You roll with it, right? That's what you got to do. All right, I'm going to have the panel tell you a little bit about how they got started with 3D here in a second. But before I forget, everybody who stays to the end of this session, whether you're watching live right now or in the replay, everyone who stays to the end of the event today is going to receive an exclusive guide that Kevin and his team have put together. So my team is going to check, if you're here at the end, check the roster, and you will receive this as our way of saying thank you for participating in today's event. All right, so make sure you stay to the end, and you will get this from us within the next day or two. Now, Kevin, I'm going to come to you first with our first question. Are you ready?
I sure am.
All right. I want you to help us understand, help the audience understand here about how you started with 3D. Specifically, I want to know, like, what was going on in your head or in your business when you began to invest not only your time and money, but also get your company focused on 3D. Take us back to that moment.
Yeah. So much like you, I've lived my life in the 2D wide format world or print world. And when I joined Master Graphics almost 16 years ago, we were selling Z Corp. It was a color 3D printer, and it was a very small part of our business. But it was interesting, and I say this all the time, we've sold printers, people need printers, they add value. But when we started selling 3D printer, we were changing people's businesses. We were improving their bottom line. We were developing new products. So, we started to put a focus on it. We still have do a very good job in the 2D piece of it. But this 3D excited me because, like I said, we were changing businesses. So that's really what we've put the focus on over the last 7 years in particular. And it's ever changing, because it is such an exciting time. And it's almost gotten harder the last couple of years. These guys will probably agree to us. So we're having to evolve as a company. And that's what gets us exciting. The reason Master Graphics has been around for 80 years is our evolution. And 3D print is just another evolution in the industry. And so that's what excites me is it leads towards our future. And it's just a really exciting arena or technology to be in, right? And it's gone beyond now 3D printing into the technologies that wrap on the front end and back end. And like I said, I think that's what makes life exciting is doing new innovative things.
Absolutely. It makes things, every day you wake up and you have a new challenge and something new to dive into as an organization and as an individual. Carl, I'm curious about you and your journey. How did your 3D journey begin? If you take us back to, kind of the spark that got you excited and got you started in the industry.
The 3D printing has always been a component of what I've experienced in product development and engineering. It's a key component of the transition from two-dimensional to three-dimensional to physical models. And Brian and I started our business in 2013 by acquiring a 3D printer and then developing the hardware. We found some shortcomings in the technology, so we developed some 3D printing hardware to improve the user experience. And going through that experience, it transformed our thinking about how to leverage 3D printing more as a manufacturing resource than just as a prototyping tool. And then 5 years ago, we started our endeavor focusing more and more on additive manufacturing as a manufacturing method using the HP multi-jet fusion, which is about when they launched that technology. So for us, it's always been there in some form, using modeling methods to come up with prototypes, and 3D printing was always the creme de la creme, the premium method to do that, and it's become more and more accessible.
Carl, I'm just curious, as an entrepreneur and innovator and somebody who's passionate about the industry here, do you remember like your first taste of 3D printing? There must have been something that you saw or something that you experienced that got you hooked. Do you remember what that was?
Yeah, it was probably, boy, that's a good question. How many years ago would that have been? That was probably 20 to 25 years ago when we were developing a product for the company I was working for. And at that point, we had an SLA stereolithography prototype produced, and it allowed us to functionally test that part. At that time, the materials weren't what they are today, so it was very brittle and it broke quite easily. But just the idea of having a part in your hand and being able to test it before you refine the design, for me, was like magic. And it still is magic, but at that point, that's probably what sparked the idea and potential.
Awesome. Well, I'm glad I was able to bring back hopefully a good memory for you and something that certainly has impacted you well, and certainly the industry as well. I know everyone's appreciative of your insights as they're going to hear today. So Brian, it's your turn now. I want you to take us back into what was going on in your head or in your life when you decided to make a career out of 3D. Do you remember?
Yeah, my journey in additive or 3D printing started in 2013 when Carl and I organized together, started our business, and focusing on 3D scanning and 3D printing, finding ways to produce highly specialized materials to make end products. That really forced us down the journey of that equipment development. How can we produce a piece of equipment that's going to make flexible, specialized materials, engineering grade materials, so that we could have custom products, whether that be something that's form fitting on your body, it cleans itself and it's removable. That was really the spark that lit it for me.
And so was it Carl that kind of got you into 3D? Were you both interested? How did that kind of play out?
Carl was the driver. He was the initial light there. And
okay.
we decided to come together, and making this journey down the 3D side was the path that we've gone down.
It was actually
That's
a
awesome.
wise auntie who was deep into research in the tech space and advised us both, you had better be in this space. So she was wise and sent us down that path.
That's right.
You're saying an aunt, a family member?
Yes. Yep.
Wow. Okay, we got to get her on the show next time. How's that sound?
Yeah, we should. That would be a lot of that would be a lot of fun.
Yeah.
Yeah, that would be. All right, Carl, I'm going to come to you first with this next question here. Folks, as you registered for the event, if you recall, you sent in your questions. And so what I'm going to do now is I'm going to start to peel those back and get the expert panel to weigh in on your questions. And like I said, as I do that, I want you engaging us in the chat. It'll help us enrich the conversation and draw out the insights that you're looking for. So this first question that we've got, it's one that we kind of got a number of variations from the participants on. And the idea, the gist of this question is that folks want to help their management teams understand how they should look at success from additive in contrast perhaps to traditional ROI calculations, ways of looking at traditional manufacturing. So Carl, I'm going to come to you first on that. What is your view to this question?
There's a couple of different lenses you can look at this question through. And one is an incremental lens where you're looking at additive manufacturing as a cost savings resource. And that's pretty basic. The calculations are pretty fundamental. But I think it's actually more valuable to look at this through the lens of transformational innovation, where rather than focusing on bottom line cost savings, which are going to be incremental at best with additive manufacturing, the viewpoint needs to focus on top line market opportunities, where we're breaking into new markets, we're transforming a market niche that may not exist today. And we can almost build that market niche with additive manufacturing because of the capabilities. So the ROI, I think if you look at it from that top line perspective and either evaluate the faster time to market, so capturing more market share earlier, and which creates a competitive advantage, or building new markets that didn't exist because the traditional technologies couldn't produce solutions to meet the market needs.
Now, I've got a visual that you sent in advance of the event. Tell us a little bit about how you use these events to drive what you're discussing there, what you just shared with us.
Oftentimes in these sorts of questions and events, the first charge is understanding what the pain points are and where the organization or the individuals are experiencing pain today. Sometimes that pain's financial, sometimes that pain is time, sometimes it's supply chain constraints. So understanding what those pain points are really help drive and optimize the ROI approach to understanding where additive manufacturing can drive and build business value.
And you use events like this to help educate and inform folks?
We do. We have events like this where we have a dynamic group of individuals from different organizations, and then we take that one step further and have tailored events at a specific organization where we've got perhaps the supply chain and engineering team, and then we can help tease out some of those pain points that they're experiencing. Oftentimes and I say this from an engineering standpoint, when we're in the heat of battle, it's really difficult to understand and break down where we're experiencing pain because we're just putting out fires. So what we've experienced at these types of events, they actually elevate some of the pains where they may be invisible to those in the organization. We can drive those to the surface and then start to identify potential solutions for those, which in some cases involves additive.
That's because of a change in the venue, a change in where the thinking takes place. Is that what you're driving at?
It is. It's partly that, and then also just looking at things through a different lens. That can happen with a different location. And changing the topic so it's not myopically or specifically focused on the products within that business. If you open the perspective a bit, you can start to see the playing field from a broader perspective.
Now tell us about this example here, what we're seeing on the screen.
So this is a great example where we experienced additive manufacturing building new market opportunities. This is the photo here is a photo of various automotive key fobs. And the problem was the OEM was producing their OEM key fob that was large. Consumers didn't like it. So what we did is we developed alternatives to that, which were customized. Some of them were smaller, some of them had different features than the OEM key fob. And in total, we ended up with something like 5,000 or 6,000 SKUs. So we have all of these different variations, and that helped open up a market segment where we solved a pain point, which was size, but more importantly than that, we added this flavor of personalization. So we built a market opportunity that didn't exist, and it really couldn't have existed with traditional additive manufacturing because of the complexities with molds and injection molding, and just managing so many different product streams and SKUs wouldn't have made sense. And most of this product is essentially made on demand. So it's a transformation from traditional manufacturing methods.
Absolutely. Audience, looking at you here, Andrew, Clay, David, Jeff, Jill, Luke. If you have questions about this specific example, don't hold back. Put those in the chat. We want to know, and I'll get Brian to answer those for you here momentarily. Brian, I'm coming to you here on the Jeep use case that we just looked at, the automotive use case here. I know from our work in advance of the session that you weren't on the market-facing side of this project, but I'm curious, how did you see that use case evolve for the business, and what were some of the benefits that you saw through that process?
Using additive with this key fob example, it allowed us to explore the market rapidly and to test and trial with finished product in real time and iterate in real time. It allowed us to gain market exposure and build upon that with other product lines rapidly without the need to have the upfront cost for injection molding or to the wait time for injection mold tooling.
Yep.
So it's really about being able to rapidly move throughout that space and be nimble in those early days within this product line.
Now, Kevin, I know that in your role and certainly in your company, the question of how folks should measure success and the return on investment in additive comes up often. So how do you guide a management team, a leadership team, to think about their investment in additive?
Well, I'm mad at Carl because he took a lot of my points and thoughts, but I think to Carl, I just almost reiterate what Carl said. Most management looks at it from a cost reduction standpoint. And I think the real point is our next evolution is when you're going to increase bottom line revenue or new markets. And I think that's the biggest thing that we are working with customers. And one of the reasons that I love what DI does is there's this focus about product innovation and going after new markets. And I think from a management side, that's one of the things we need to work on. And then as an engineer, a lot of times they want to acquire equipment or outsource because it's cool. And I think part of our challenge is engineers got to start understanding. We always talk about pain. What are the pain that management's experiencing? Do they want to get market share? Are they losing market share somewhere? Is the customer asking for something? So to me, going back to you, what Carl does and Brian with the workshops, you kind of get out of the whirlwind and you get out of the day-to-day solving the problem and you go, where do we want to go? And to me, that's where the return on investment starts, because you start small, incrementally, and then you grow, right? You take your key fobs, they go to doorknobs, whatever, door handles, not knobs. But I think I kind of equate it to us when we first got into 3D print, we were testing the market, and now we're fully in it and we keep building around it. So, but ROI is very complicated, but I think in most cases, we look at it wrong because we don't look at it holistically as an organization and what the organization wants. And that's where engineers got to talk to management and relate to what their tasks are, if that makes sense.
It does. It does. I want to hear from the engineers here in the audience what you think of Kevin's response there and what some of the challenges are for you specifically as you're thinking about how to interact with management in the way he described. So drop that in the chat if something comes to mind there, folks. I want to hear from you. Carl, I'm going to come back to you on this example that you just showed us here a moment ago on the screen. Question from Jeff in the audience today. How many colors does the printer support at once? And do you have to change colors for each of these orders? Give us a little context on how you do that.
Great question. And I'm going to call on Kevin because I know he's going to know some of the more specific details off the top of his head. But the machines that we use to produce these parts are CMYK, which is it's the same as what's used for inkjet paper printers, essentially, same color band. So I think we're in the 16 million.
The HP does not publish the number, which is kind of frustrating in some ways, but it's literally millions of colors you can do without, again, the mixture, just like you do on an inkjet printer.
Right. So we're not swapping out color cartridges. It's load the color cartridges CMYK, and then produce the parts, and then as those cartridges empty, then we replace them.
So, and the beautiful thing in that image, if you take the key fobs in that middle section, those could all be printed at once. That's the beauty of additive that you couldn't have done before. They can all be customized. And I think that's again, a shift in mind thinking that you can actually customize on that kind of scale.
Yeah.
Amazing. Jeff, did that answer your question? Yeah, it is cool, Jeff, right? If you have any follow-ups, Jeff, let us know. That's what we're here for. And great question, Jeff. Thank you for that. All right, second question here that came in from you all who registered and submitted your thoughts in advance is around the idea of quality, and specifically, how is quality in additive assured, and what kind of processes are used to ensure repeatability and obtaining quality at that kind of level? And there were many questions that came in around that and how it compares to what we might experience in traditional manufacturing. So Carl, I'm going to come to you first on this one. How do you look at quality, and what are your thoughts around how to ensure what we're looking for from a quality perspective?
It's really a great question. And, there are so many different perspectives about this topic out there in the marketplace. And when you hear from some of the printer manufacturers, it can be easy to misunderstand the capabilities. And I think the first response to this is additive manufacturing, so 3D printing for production, is a manufacturing method like any other. It's like injection molding, where it has to you have to have process controls, you have to have controls of your material streams, both raw and reclaimed, and then you have to have controls over your environmental, the environment that the printer runs in, humidity and temperature. And then all of the downstream processes have to be controlled. And there's a misunderstanding, I think, in the industry that printers, because they are more self-contained and less intense to install than an injection mold press, that they can then be placed into service and produce consistent parts right out of the gate. And that really isn't true almost for any of the technologies. It requires developing a process control, which sometimes is specific to the parts you're producing, and then having a workflow that is tightly controlled and locked in terms of process. So that's really the first step for us, is locking the materials, locking the process settings, locking the workflow, so that when we're producing parts, we're doing it the exact same way every single time. And then we've got secondary processes to validate the quality. And then we can adjust the cycle or adjust the processes if we need to. And this is a couple of photos. This shows a photo of a deviation analysis on a part to understand where it's deviated from the model. In this case, we're using a digital CMM to assess the part. Of course, we don't do this on every single part for the CMM. And then this shows some photos of the inspection process and the final stages of quality assurance.
Fantastic, and great shots there. Folks, if you have questions about what you're seeing here, let us know. Thank you for sharing these photos, Carl. Greatly appreciated, I'm sure helpful to the audience. Brian, a question that I'm going to pose to you, and it's a variation of the one that I just asked that we received, is how do you manage quality at scale? For example, when we're talking about, let's say, thousands of parts per day, it's, I think, easy to say we're doing it for maybe one or two parts, right? But how do you see quality managed when scale comes into play?
It's a play off of what Carl went through. Of course, we've got to collect data. We have to have locked processes, and then we have to do data analysis. But the most important part is making sure that we are following, or you're following, a part to production process. And that's having the sample runs at the very beginning to make sure expectations are known. It's having pilot runs, making sure that we're meeting those expectations. And then it's monitoring that production over series or batch production to make sure that we're not deviating from the dimensionals in long-term production. But if you don't go through that ramp-up phase, it'll be impossible to scale. So it's about taking the small steps early on to make sure everything's been covered.
Got it. Got it. David in the audience is asking, what is the tolerance you're using for the inspection?
That is highly variable and dependent on the application. We have some that are 0.05 millimeter. I believe that's in the 1 to 2 thousandths range for inches. A lot of it is in the plus or minus 5 thousandths, plus or minus 8 thousandths. Whatever the application demands, we build a spec or we collaborate with the client. I get that in line with what we can achieve for the pricing they're looking to get.
David, let me know if that answers your question there. Thank you for sending that in. All right, Carl, I'm going to ask you this one here. This a question that we got from a number of folks here around the idea of if a company, if an organization, if a team is looking at starting with production additive, using additive for production, the question really is around what are the top strategies for thinking about how to do that appropriately? And so, Carl, come to you again. I want you to tell me the strategies that you would suggest that folks consider when thinking about how to use additive in a production use case.
Boy, this is a really good question. And it's a tough one because it is dependent on the types of applications. But the first thing I say is intentionality is extraordinarily important. Going into, and what I mean by that is going into additive manufacturing to greenfield an operation, the understanding of what it takes to get it done and the upfront work, somewhat like what Brian was saying, the upfront work to bring a product to a production scale through the various different steps requires a great deal of effort, intentionality, and time. So if there's an organization that's thinking about bringing on AM in-house for production, then that initiative should start 12, 18, 24 months before the production actually takes place. And that allows the team to understand what variation can we see, what should we expect, and how do we change our process controls. And the 18 to 24 months is probably for the higher tolerance, more critical parts. And if they're parts that are more forgiving to dimensional variation, then that can probably occur in a shorter period of time. But the fact is there's a lot of learning that needs to take place for a team to greenfield a production facility. It's taken us, it took us 3 to 5 years to get to the point where we can really master the machines and be able to produce with a great deal of predictability. But even today, we're still learning, and there's as much art as there is science into being able to predict most of these technology capabilities, even the most robust.
Carl, let's share here. I'm going to ask you to be vulnerable here, just with us and the friends that are here in the room. Okay, a couple moments here of vulnerability. I think it's important to speak of not only the successes that we have with additive, but also failures. Things that we learned along the way through failure. So, first of all, I'm making an assumption here, but have you experienced any failures? And if so, tell us what you learned out of that experience in this process.
Yeah, we have. In fact, I think it's getting hot in here. Speaking of vulnerability, we have, and we continue to experience failures. I think there's a photo in one of the following slides that shows a cabinet that we have full of parts. And that's just a small snippet of the types of failures that we have. And oftentimes we're overrunning production just to understand how to be able to produce parts with a level of consistency that's required. And when I say overrunning production, I mean we're running intentionally more parts than we need so that we can be able to do that in a scaled production and understand the variation that we're going to see. And it really isn't a known science, and we have failures. We certainly have more failures than we'd like, and more failures than that would be acceptable in a traditional production environment like injection molding.
Yeah. Brian, what about you? Give us an little peek into maybe a failure or something that you learned through something that didn't go the way you expected that has illuminated a new way of thinking for you or has brought you a new insight in the work that you do.
Well, in all manufacturing, additive in particular, failure is really important. Without failure, we're not able to understand how do we make it better next time? What are the really important processes that are driving this failure mode that we experienced? I think the most common failure that we do experience is going too quickly to production and expecting that things are going to work out. It always takes longer than expected, and there's always unknown constraints that we learn along the way that bubble up. So we've learned to expect it and then train for it as much as possible.
Fascinating. Kevin, what about you? From your vantage point there at Master Graphics, what would you say relative to both the question that's being asked here around how should a company think about strategically breaking into production additive manufacturing, and then also the other side of that, which is, what are some of the lessons learned from failures, things that didn't go right in that process?
Well, I mean, first thing to build off that failure is always good because you learn from it, right? And if you're not failing, you're not trying enough and you're not pushing the boundaries. But I think you have, I use Deloitte, and there's a lot of good information for listeners out there. Deloitte does a lot of great articles on additive. And I think one of the challenges that we continue to see is, what do people really want to accomplish? We talk about this as a group here. You got to start with your pain. What do you want to improve on? And I think as an industry, we have a hard time focusing on that. But if you look at the 4 quadrants that Deloitte lays out, most of us are in the lower left corner where we're not changing the products, but we're using additive to kind of augment it. Think of tooling, fixturing, and prototyping. But then as you move like to the right-hand side, this is when we start moving production to where it's needed. Think of, we're working with people such as John Deere, where eventually they'll be able to print parts at the dealership or remotely. And that's a next evolution of additive. And as a company, you have to look to where you're at and what part of this segment you want to improve. And then, of course, if you go to the upper left there, product change. This is where we're getting into things like, you see this in shoes, right? Where they're doing different type of soles and that type of thing to improve it. And that's another way. Lightweighting, GE is always the standard bearer with their metal engine or their fuel nozzle. And then business model transformation. This is, to me, the ultimate. If you look at what they're doing with their Freedom product or 3Dom product, and even like in our case, we have a client who prints figurines. And now they've transformed that whole industry because it's app-based. You can scan yourself. You then can get a model. You can use it as an avatar. And to me, this is business model transformation. They are competing with the Mattels of the world in these. And so you really got to look at these segments or quadrants, in my opinion, and decide what is the area that we can focus on. Because this is well beyond printing. One thing I've learned in this, the printers are one segment of it. As you start to transform your business or move to these other areas, as an organization, you need to change your input processes. You need to change your output processes. You need to change the structure around it. And so to me, this is a good framework to use. And I think we'll share it in the downloadable piece of it. But I think it's a really good way to look at it and where you're at and where you want to go, and just be very concerted effort of where you're going to go with that.
Fantastic insights there, folks. And if you have a question for Kevin or Carl or Brian, please drop that in the chat. Mobin, hopefully I'm pronouncing your name correctly. Forgive me if I'm not. I want to read what Mobin said here about the aspect of failure. Failure is always an option, right? But giving up is not an option. And that's the best part of additive. You can always adjust and try again. Completely agree with that. A question here from Mehmet. Again, forgive me if I mispronounce any names. From your experiences, what items, features, volumes, etc., that you've learned don't fit the process well that you would suggest to avoid? Carl, I'm going to come to you first on that. How would you respond to that? Put you in the hot seat.
Yeah, well, it got warmer in here. The best answer that always exists for additive manufacturing is it depends. We've run, because it's so situational, right? It's so contextual. We've run volumes as high as 100,000 parts. I think that depending on the geometries, when you start exceeding those numbers, you're probably running into an economic ceiling that would be better served otherwise with additive manufacturing. We've run into geometries and smaller parts or larger parts that don't work. And a lot of it has to do with the technology you're working with and the objectives. And probably the biggest challenge is misfitting a solution with a technology. So in other words, if you're working with very, very tiny parts that have a lot of delicate features, a technology like multi-jet fusion may not be the best solution. And so it's really right sizing the way you're going about the method and then the solution that you're trying to achieve. It'd be interesting if you have more detailed scenario or questions about that. It'd be great to connect offline and talk more into that.
Yeah, just to add to that, there's no easy button on the number of items you can print. We get this all the time.
Yeah.
And that's why I think we don't spend enough time, because we're in our whirlwind of really understanding what the application and need is, because that answer could be one and it could be 30,000. And even in injection molding, right? One might make sense and one doesn't. So I think that's one where it's definitely increasing, right? If you look at technologies out there, carbon, HP, things are changing from a volume perspective, but you got to assess it on an individual basis. There's no clear-cut answer.
Okay, audience, I want to ask you a question now. I'm going to launch a poll here on the screen. It's going to help us understand you better, and also you're going to get a sense for where everyone else in the room is on a particular topic. And so specifically what we want to know, I'm going to launch the poll here. You should be able to see it here on your screen in just a second, is does your company have an additive manufacturing plan? Now listen carefully before you answer, with specific goals and targets that you're tracking against, okay? So you have a plan, but you're also measuring against specific goals and targets. And we've worded that very intentionally. I'm going to give you a moment here to respond. I want everybody to get out there and vote. So look at your screen. Go ahead and pick the option that's best for you. Yes, we have a plan with specific goals and targets that we're tracking. Yes, we have a plan, but not with specific goals or targets that we're tracking. No, we do not have a plan. And of course, what's a plan? We will see where this ends up. And then, Kevin, I want you to kind of give me your take on what we're seeing here, folks. Come on, go out and vote there. Take a moment. Give us which of those options best answers the question here for you as to whether or not you have a plan with specific goals and targets. Going to give you another 3 seconds. 3, 2, 1. Bring it to a close, and I am going to share those results. And Kevin, what do you think of what you're seeing here?
No, it actually aligns a little bit what I think. I mean, I'd love to know the people who have targets and goals, what they are in that space, because I think generally we find people think they have a plan, although we're having 47% say they don't. But that's why you need to engage DI Labs. And then, of course, like David Tucker does his Implement AM, I think it helps you develop the plan. But yeah, so I would say it's actually people are being more honest than I thought they would be. Good job.
Maybe I did a better job asking the question this time. This is a question I know, Kevin, you and I have asked other groups, and I think we got a little bit of a better response here. It's the old garbage in, garbage out thing, right? Carl, were you going to add something to this here?
No, I was just going to say that this is what I would have expected it to be with an honest response. Yeah. It would be neat to drill down on some of these answers. It would be interesting. Yeah.
And we can help the 6% with what a plan is. We'll ask AI and send that answer out afterwards as well. I'll do an addendum on the download.
I bet the what's a plan person is highly creative, inventive, maybe a Thomas Edison type person that says, hey, let's just figure it out as we go along. I love that. Thank you all for giving us your insights there. That's very helpful to us. And we appreciate you taking the time to vote there. All right, the next question I'm going to flash up here on the screen. Kevin, I'm going to come to you first on this. We had a number of questions about material options. What's available for additive in contrast to, for example, what's available in injection molding? So what would you say to someone who's asking that question?
Well, again, we get this question all the time, much like the volume. What I would say, it's the wrong question, because what you really want to do is focus on the application and what the outcome is, to understand what you're trying to accomplish. Is it going to be effective or more valuable than traditional processes? Obviously, there is a reason we compare it, because we're used to injection mold. But I think there's actually a hindrance because people use old specifications, or they don't want to look at new ways, or the specifications were written on that process, but isn't really related to the part. So I know a lot of people don't like that answer of not A through B, but that's really the case. And I'm going to try to sound smart, and this may not come across as I was driving here today. I was thinking it's like pants, right? Pants, everyone always made cotton and jean material, and then Lululemon comes along and they develop a new material. And what were they doing? They were solving a problem to make a really wearable pant and really comfortable and real valuable, right? And now, obviously, you still pay a premium for them, but everyone else comes out with this different material. And if they only looked at the material they were using for pant 20, 30 years ago, and I'm not a textile person, so I could be wrong on all this, it wouldn't have changed. And I think the same things with additive. What are you trying to accomplish? And then figure that out, if that made sense.
Carl, what's your view on that?
Story in the future?
Yeah, I think I agree with Kevin in that the material tends to be the first question. And then oftentimes our question back to that is what mechanical properties, what physical properties are you looking for? And you could swap this out for what material options are available to what printing methods are available. And it really comes down to what's the application and what are the requirements for that application to be successful.
If I can add something to this, in fact, because we're going to talk about this in Implement AM next week in Milwaukee. A lot of times, this is a process we use at Master Graphics. The question being asked is not the real question, right? And so when they're asking about material, what they're really asking about is functionality. And so that's why you got to reverse those questions back. And even in your mind, I think when you're looking at asking that question, you got to reverse it and say, really, what is my real point in asking that question? And so I think it's really good to keep in mind that why you're asking that question and start from there to get to the real answer.
Brian, what do you think about Kevin's pants idea?
I think the pants idea is the perfect analogy. Starting with the constraints, what is it that we're working with, whether it's regulatory, functional. If there's a like material that you're starting with today, we often navigate those conversations to align with either a material we can produce with or a different journey. But there are a tremendous amount of options out there depending on what your application is.
Now, Carl, we hear a lot about companies that are utilizing 3D printing to manufacture final, use parts in production. Again, just between us here in this virtual room, I want to ask you, is that realistic? Tell us really what's going on there and share some insights that help elucidate the actual, use cases that you're seeing and whether or not this is actually a practical thing in the market today.
It sure is, and we're doing this. The 100,000 part example that I shared earlier is a great example of using additive for full production, and we're doing this today in several segments from defense to medical device to consumer goods, and we can attest it is possible, it's realistic, and it can be successful. But understanding what the objective is first and foremost before you go into questioning whether or not production is the right resource for additive is super critical. If we generally say if you can injection mold a part and it solves the problems that you're looking to solve, don't 3D print it. If you're looking to 3D print it because you need 5 versus 50,000, then that probably makes sense. But in most cases, a direct swap from injection molding to 3D printing just doesn't make economic sense. But but we are producing in full production today on several different product lines across different market segments.
Folks, please ask your questions, push back on that. Let's draw out insights, because I know this is one that's of importance to many. Brian, I want to know what you think. Is final use parts realistic? Give us a little counterpoint there, maybe to what Carl just shared.
Yeah, so we covered a couple areas, quality and starting AM with production. And those are the necessary components to make final end-use parts, whether that's for consumers or if it's going into an assembly. It could be its own product, or it could go into an assembly, or it could have some other manufacturing need for another product line. But with the right quality and process setup, we are making end-use components today.
Mark, I see here in the audience that absolutely we're having great success with production parts. Mark, just curious if you're willing to share there in the chat. Give us a little bit more detail about what you're doing and how you're using additive for that. Kevin, I'm curious for you, since you get to see a large number of different types of organizations like Carl's, as well as the end organizations who are using additive. I'm curious how often, if you could just give us some context, like how often are folks coming to you, or are you running into folks who are looking for production, final use part use cases versus prototyping? Roughly, what does that look like?
I think it's more the anomaly on production, because people have been burned in the past when we overhyped it. And I think so, but we're starting to see that, right? You have people like, there's a Smith Goggles that does custom goggles. Think about perfect application, right? You're skiing and you need them to fit right. You have Bauer doing some different helmet inserts, right, to do that. Brooks Shoes coming out with a 3D printed sole. So I still think we're still trying to understand what that is and the change in it, right? We still mostly live in that prototyping phase. But the other one I think we see more of is kind of this bridge manufacturing. We got an idea, we need to fix a product. And so I think we're starting to see bridge manufacturing, and then people realize, wait a minute, we can actually do this to scale. Again, a lot of times it doesn't always work, and it is bridge manufacturing for a reason. But I think we're still, kind of figuring that out of what the real capabilities are. The other thing I would say on production side of things, and I'm stealing this from David Tucker, and obviously he's smart enough to get invited by MIT. So,
yeah, it must be worth stealing.
Yeah, right, exactly. I mean, I'm going to Harvard next week, but I'll brag about that later. But it's interesting. He says additive manufacturing is the reshoring tool. So I think another thing beyond just the economics of everything, additive is going to give us the ability to reshore in a time where, I don't want to get political, there's political unrest, and we want to bring some of that manufacturing back to the US. So there's just that's such a complicated question when you talk about going to production and really what that means. But the answer is we're at a tipping point. And again, I think the problem we have right now is understanding the processes on the front end, the expectation, people change in the way they design and look at things, and then of course output. But again, it's why people like DI Labs are thriving, because there are partners out there. Most of the time you're going to go out to a contract manufacturer. You're not going to do these things in-house. As much as I'd love to sell everyone a printer.
Yeah, no, I understand. Thank you for the honesty and transparency there. That's helpful to the industry, of course. Carl, tell us what we're looking at here on the screen. Give us an example. Walk us through this example and help us understand the implications.
So this is a great example of full end-use production. In this case, it's got a lot of different nuances to it. So these are, what's shown on the screen here are basically aeroponic baskets. And in this case, they're for lettuce. And we had a problem, and a need to develop a better aeroponic basket that allowed us to grow certified organic produce. And through that process, we knew early on that additive manufacturing wasn't going to be cost effective for the end use production resource, but we also recognized that we could produce those baskets in a high enough volume to be able to design and test and put into a full growth cycle these cups with the lettuce. So we were able to do that. We designed these so that we could produce them at about 1,600 baskets per print build. We went through, over a series of 90 days or so, we went through 10 rapid iterations where we produced about 16,000 baskets and made iterative design changes and then measured the results. And since we were designing these at that scale, we could actually measure the results of the produce. And what we discovered is that we were able to increase the yields of the produce, so more lettuce, with the same growth pods by about 30%, while also
Wow.
decreasing the growth cycle. So more lettuce in a shorter period of time. Ultimately,
Wow.
this was designed for injection molding, and we knew that early on, but additive was the only resource that allowed us to go through this highly iterative design to get to the results that we did. It more than paid for itself just from the results and improved produce. It was like a benefit that we didn't expect, but we were able to design into the outcome.
Kevin, I'm going to come to you here. Do you know Mark here in the audience? I don't know if you can see Mark's question here on your end. I'm going to read it to you, Kevin. Mark is saying that you might be able to speak to this further. He says, we replaced a simple 4-piece weld meant with a Lux injection molded plastic bearing cover for safety. We print it in ABS in bright yellow. We save 20 minutes of weld time, paint time, laser brake press time. I can print one in an hour, which probably equals total metal production time, but for 30 cents, and it looks incredible. Kevin, you have insight into that use case?
Yeah, Mark Harwood, one of my favorite people, truly. We worked at Master Graphics many years ago. But yeah, no, so they do industrial machining, and they need like cap covers. And what they would used to do is have to get them injection molded. And now for those cap covers, he can 3D print them, and they're final use parts that go out to their customers. And really they're simple covers, but they are much harder to traditionally manufacture than 3D print. It's a perfect use case scenario of using a part on a final use product. So yeah, no, it's a great application.
Thank you, Mark, for sharing that. I know, folks, we're coming up close to the end of the time. Please stick around. Thank you to the panel for being so gracious with your time. I'm going to try to get to a few more questions and then go into real-time Q&A as you're led here, audience, to ask questions of the panel. I'm going to ask the panel. I'm going to go with you, Carl, first, Brian, and then round it out with you, Kevin. I want to know from your vantage points, each of your unique point of view, what is the number one challenge you see when companies try to implement additive beyond prototypes and tooling support? Carl, what is the number one challenge you see?
It's probably first getting the teams to seriously consider additive early enough in the process that it can be built into the plan from day one. The later you consider additive manufacturing as a production resource, the harder it's going to be to implement it. And that's probably the number one. And then as secondarily to that, the later that falls, so if you've got your design locked and you're evaluating manufacturing methods and you choose additive, the spool up time to that additive is significant in order to get to a high quality product. The earlier you can consider it, the faster you can go to market and benefit from the development time, using additive in the development time.
Good. That's helpful. Brian, what would you say is the number one challenge you see?
Making sure that the application is aligned for this additive manufacturing process is it's really nuanced, and if there's a hurdle to overcome, it's one that often gets hit. So, being very thoughtful about the application and making sure additive is the right fit for it.
Kevin, what about from your point of view? Number one challenge?
Man, I don't know. That's really hard because there's not just one, right? Sometimes I would say the team is probably not where you start. It's, the management has to have that goal in place. So I love the people who responded with real specific goals and outcomes. I mean, I think ultimately two people look at the printer and they define their success or failure on the printer, not on the process. I kind of said this earlier. So I think it always comes down to, we probably don't spend enough time on what we're trying to solve, what's the issue, and that it might not be a problem of what production problem, but a market you want to go after. And I think sometimes we just don't, as an organization, and this would go to the teams, really get together and understand where's the company going and how can this be a tool in the toolbox or a production resource. So, but that's a very complicated question. Sometimes it's political, sometimes it's personnel, sometimes it's the environment. But so I didn't answer that. There's lots of them.
Got it. Got it. Jeff, I see your question. I'm going to throw that to the panel here in a moment. For the rest of you, if you've got a question going on in your head, that's what we're going to go to next is Q&A with the panel. I've asked them to stick around a little past the hour here, and hopefully you can as well. But in the meantime, as you're getting your questions ready, I want to give you an opportunity. If there's something that Kevin or somebody here on the panel has said today that you want to learn more about, my team, please take the URL that you see here on the screen, 3d.mastergraphics.com, drop that in the chat. And folks, if you're here and you have a question about anything you heard about today, you want to speak one-on-one, maybe with Kevin and the Master Graphics experts there. You've heard that Kevin is passionate about bringing you knowledge to advance the industry and whatever you've got going on in your organization. So take a moment. What you'll see there when you go to that form, you see a page that looks like this. Fill that in, and Kevin and the team will set aside some time to speak to you about your unique situation. So Kevin, give us a little bit more context here. Tell us more specifically about who can you help, and in what situations are you best suited to be able to help folks think through their challenges, their hopes, their aspirations, their needs, to make the most sense of how additive can help them. Who are best kind of folks for you to help through that process?
Well, again, I think it's clients or people trying to look at new markets, trying to grow their top line revenue, or trying to be innovative in their product development. I mean, that is really it. We're still going to do those traditional tooling and prototyping applications. Those are more simple. But I think if you look at today, the reason I think what comes out is you want to have conversations about your business, and I think we have a framework for that. And like I said, I think we need to know what your goal is. Is it product innovation? Is it new markets? And I think that's if you fill that out, that's what we really want to do. 99% of the people we talk to are not going to buy a printer, and what we're going to do is connect them with the DI labs or other partners, or help them with the software tools. But I think most people listening here, it's really about the interaction, and it's hard to trust people. Like DI didn't know me for years, right? And over time we realized, hey, we think alike. We can do good things together. And I just encourage, especially in the Midwest, we have such a great business culture that you spend time to reach out and yeah, obviously we make a living selling things, but ultimately I think we're all altruistic in our view. We just want the Midwest in particular to grow from a manufacturing perspective. And we do a lot of connecting more than selling, right?
Kevin, did you say you're going to be at an event next week?
Yeah, so Implement AM is Milwaukee. David Tucker is one of the ones who started that. So if you look up, Google Implement AM, he just sold it to SPE. And if you need anything or have any questions on it, send me an email. I think all my information goes out.
Perfect. Now I'm going to throw some questions at you all. Just go ahead and wave your hand or answer the question that you feel most called to. This question came from Jeff. Jeff is asking for prototype development. How do you compare 3D development with job shops, I assume like service bureaus, versus owning your own machine? Who's got perspective on that?
You can go. Or Brian can go.
Go ahead.
Throw it to you, Brian.
No, I think it's two different. I mean, I can answer. Look, they're two very different things. That's application based. Like, again, a lot of times I say this. Sometimes you have a 3D printer to develop the product, and then you're going to go out to contract manufacturing, right? Like, I'm not. At one point, we thought selfishly we sell HP. Where again, I keep using John Deere. I must have drove by a tractor on my way in. That John Deere was going to run 100, HP machines. I think ultimately they would have a unit in-house, and they do to develop a product, and then they go out to contract manufacturing. If you do need very tight tolerances and process control, a lot of times you're going to go out for that. So that, we keep talking about application needs, but I think that's kind of where they both play. I think it's important to have printers in-house to develop internally, but then it is even more important to have an external partner, again, selfishly, because I feel so strongly about DI, that's going to help you along the process and have resources that you could not afford to have inside. You think I answered that all right?
Yeah, I think so. It's more about knowledge than it is the service. And so I thought a lot about that question, and I agree with what you're saying, Kevin. So we've got a couple of different businesses, and one of our businesses is a product development service provider that we develop our own products that get manufactured by DI Labs. So we leveraged Labs as an in-house service provider. And besides the manufacturing quality, it's the knowledge that we get as we're doing the development. So whether you're working with an outside service provider or working with an inside service provider, that knowledge is really critical. And you can get both from both places, and you can also be stonewalled in both places from a knowledge standpoint for whatever reason. So I'd say it's most important to make sure that whoever you're using, they meet your objectives, and knowledge is really, really important and often underrated.
Jeff, let us know what you think of that response, both from Carl and Kevin there. It looks like, Jeff, you have another question here as well. I'm going to hit yours next as well. Do any of you 3D print metal?
We do offer 3D metal additive manufacturing services. Yes.
Yeah. And
Jeff, there's the yes.
Yeah. And we sell desktop metal. I think metals, again, plastics is hard. Metal's a different world.
It is.
And you go back to expertise. That metals are really important, that you have the right partners that you're talking to on that, because it's a different realm, right? I mean, it really is crazy. Yeah.
And the value proposition is different because of the cost of operation.
Yep.
Audience, for those of you who are here, Andrew, Casey, Clarence, Klaus, Luke, Mark, I want you to be selfish right now. Ask your questions, as I said there in the chat. Be selfish. There's a lot of experience here in this room. Ask your questions. I'm going to take a few more here and try to get through as many as possible here in just the next few minutes. So Clarence has the next question here. Clarence is asking or saying, my in-house challenge is many people don't recognize AM as a tool and or a step in the process, but as the solution. And this is not always the case. Any suggestions?
Well, in order to get others to believe in the technology and it's the right fit for the application, I mean, of course, it takes a lot of trust building. Just like if you were to step into injection molding for the very first time and no one heard of it and they hadn't experienced it, it's going to take a lot of trial and error in order to showcase the possibility and to show positive outcomes from that. So I think it's relentless effort through the process to find the right outcome that you're trying to achieve with additive.
Carl or Kevin, any other counterpoint to that you want to provide?
Man, that's a tough one, because I think just beyond, we start usually, again, we go back and we teach people on technology. And I think the hard part when you're doing things internally, it is about education, and it's not just about the printer. And I think sometimes failure as well, right? We go back to failure as an example. I think a lot of times when you're doing things internally, the first time it fails, if it's not communicated back of why it failed and maybe why it could be different, then they give up on additive. So that's, I do think, getting back to our next evolution of really taking additive to another level, going from 3D print to additive, it is that ecosystems got to be more educated and working together harmoniously. And again, experience failure together and figuring out how to get better. But that's again, another one. All these questions you could talk about in 5 different ways.
Kevin, tease that apart a little bit further, where you said going from 3D print to additive. Be specific about what you mean in that transformation or in that journey. What are you alluding to there?
I mean, again, the definition, of 3D print is probably additive is probably the same, but I think we've been 3D printing. Like, that's where I talk about tooling and fixturing. Most people can 3D print. I can 3D print at home. I think when I look at additive manufacturing, now we're getting to it where we would call it end use parts or new products. It's a different level of just printing a tool or a fixture or a prototype. To me, additive manufacturing is like the key fob. It's like the Bauer helmet. It's like the shoe. Now we're making a new product. And to me, that's additive. And there's 2 different spaces. And going back to the quadrants, I think most of the bottom left quadrant is 3D printing. And then as you move to the other quadrants, now we're in additive manufacturing.
Got it. Helpful. Audience, I have a question for you, and I want you to take a moment and give us your best response here, okay? I want to know from you, what is it that stood out to you today through this discussion? For example, an insight or an aha light bulb moment that went off for you that gave you some information or some insight that coming into today's session, perhaps you didn't have? I want you to take a moment, think about that. I'm looking at you, Andrew, Casey, Clarence, Luke, Mark, Roger. If I'm calling out your name here, I know there are many others as well, but Ryan, Scott, Tyler, Zeke, I want to know what stood out to you today, and take a moment and drop that into the chat. I'm going to give you just a moment to think about that and then give us your response. I'm going to read while you're doing that, while you're thinking about that. Jeff just sent in something a moment ago here. Jeff, thank you again for your participation in the event today. Jeff is saying, thank you. We've had issues with sending out additive manufacturing jobs and getting parts back that do not work. However, different jobs require different machines, and buying one before you really know what you need is a challenge. Having a partner with multiple processes that could really help you develop a part would be great. I guess instead of writing a contract to make a specific part, we should have a contract to develop a part with multiple iterations and value-added knowledge from the vendor. Carl, I imagine you would agree with that. What are your thoughts on what he said there?
Jeff, I love you, man. I feel like what you just shared is something that we feel very strongly about, and it's often undervalued, at least until it's too late. And there's a lot of cost and time involved in not doing that. But I couldn't agree with you more. That's something that, as we've talked about additive being successful, I bet you we've spent maybe almost as much. I'm trying to think about the numbers. We've probably spent half as much on R&D and printing parts to understand the machines as we did in buying the machines to begin with. And so it's a significant investment. And I believe that type of investment is required in order to obtain the knowledge and the understanding in order to be able to really leverage the technology to drive value. And putting parts into a machine, anybody can do, but that's not where the value comes out.
Yeah, and if I can add to that real quick, and the way I phrase it is, traditionally we use the term service bureau, and you're right. You take an STL file, you load it, get a quote, and it prints out. I think our next evolution, and I think somehow we got to almost segment it. You guys came up with solutionologists. There's got to be another one, like I said, a contract manufacturer. That's the next level of interaction to improve the overall results. Because again, I think one of the challenges we have is if you have a part and again, you send it out and there's not the right tolerances, there's not the right processes, it comes back, it doesn't work. You believe that doesn't work because the printing process, and sometimes it's the other processes around it. So I think I always distinguish between service bureaus. You want to upload it to Xometry, that's one way. You want to go to an expert with product designers on staff, there's other places to go with that.
Fascinating. Mobin, you're saying here one of the things that stood out for you is that additive manufacturing is not a magic cure. That's what you learned. Thanks for sharing that, Mobin. Right. Clarence is giving you kudos on the Deloitte chart, Kevin, here. He said the chart developing an additive manufacturing strategy, the 4 quadrants, is useful, which I will be sharing with my team. If anybody wants that here, if you want to get a copy of that, drop your best email in the chat, and we will make sure we get that to you and to your team, the chart that Kevin shared. Mark is saying here, I think someone asked, but how are you tracking production time on a 3D printer? In a small shop, it's hard to track one user's time to maintain and operate when it's an hour of maintenance here and there and 2 minutes of grab fresh print and cleanup while pushing print for the next one. So overall question is, how are you tracking production time, especially in a small shop? Kevin, I'll go to you first. What are you seeing in the industry right now for that?
Well, I mean, I think Carl or Brian would be a little bit better, but I'll answer that. I mean, I think that's a challenge because I think what Mark is talking about is the overall time from hit print to finish that. And again, this goes back to my thinking that we need other tools around it. So there's other things called 3D Print OS that will actually track your print times. It will track your workflow. It will track all of those things. And I think then it's harder in a point process to track that time versus like the production environment you guys have. But I think, again, we're going to continue to see more tools that will help people use distributed 3D print and understand time to print. Does that make sense?
Is the 3D Print OS, is that the HP software?
No, it's actually it's very close to that, but it's, again, anyone wants to do it. It's a third party that manages fleets of kind of entry level machines, and we don't sell it, by the way. But I'll point you to them, because they do one of the challenges we have, like Mark, if he's got 5 parts to print, or when one guy's got 2, they struggle over the printer, so they don't really know the workflow. And there's softwares out there that are starting to do that.
Well, Brian, let me come to you. How are you thinking about tracking production time on a 3D printer, especially in the case of a smaller shop?
We navigate that with a system that allows our team to track individual jobs that come through the system. It can be challenging because with multi-jet fusion, you have a one-to-many scenario where you have lots of different parts in a build, but you have time associated to that whole build. So how do you separate that out to each part? We don't go to that level of detail, but having a strong system in place that you can build up and you can have processes logged in real time rather than having to manually enter, that has been our approach. You got to have some automation built around it.
Carl, any additional thoughts on that?
It's really tough for a small shop because there isn't great software out there. We've ended up building our solution ourselves over the last 24 months or so, using an ERP and MRP platform. That was no small feat, and that's something that we really struggled with before getting into that. But we found that we had to develop it ourselves using an existing platform. It's a tough one.
I see. It is tough. Yeah, I see Mark. Thank you for your comment here. I think Mark is saying what stood out to him is knowing that high volume additive manufacturing parts for end use are being utilized, and that's very enlightening. I'm glad to hear that, Mark. Thank you for sharing that. Clarence is saying, I love technology to include 3D printing. Any suggestions how we get the most out of our 3D additive manufacturing journey? Clarence, I suspect the panel's going to ask you for more details around specifically kind of like where you're trying to get more out of it. But in general, Carl, you want to start with that? How does Clarence get the most out of their 3D additive manufacturing journey?
First step is identifying what you want to get out of that journey, identifying the objectives, and going into it with a blue sky approach is going to be tough because you've got to get buy-in from your key stakeholders. So I think first and foremost is getting alignment within the organization of what your key objectives are that equals success. And then that's a huge step that the rest of it will more easily cascade from there.
Kevin, you have any insight?
Man,
any suggestions?
I keep jumping in here, but I think where I might take a little tact a little bit differently is I think that's why, like, what's excited me over the last year is like events like you do, that DI Labs do. I sound like I'm a commercial for Implement AM, but the reason we do these is because these are to me, the most intelligent people in the field. And I actually think that's the way to do it, is to get offsite, really understand what you want to do and work with someone as a process. Again, it is hard. As a reseller, most people think we're trying to sell them a certain technologies. That's why I think agnostic people such as DI, because they have other technologies, David Tucker, I mean, even the MIT class that he's teaching is available online. So I really encourage you that if that's what you want to elevate that technology, we have to approach it more professionally so it aligns with management. Because right now, in most cases, management, we don't align with what they want. And so, but I'm a big proponent of workshops. We do it. We're here in a marketing, you do it, David. Like, it's best to have a workshop and you kind of walk away with 2 ideas. These are what we're going to work on. And I just think we need to spend more time doing that. It's a lot more fun than talking about printers. Yeah.
Yeah, for sure. Zeke is saying, like most areas of work that people deal with, most problems and failures are the things that you learn from the most. Trying to do something in-house may lead you on a long road to develop what others have already learned. Interesting and very wise to use overproduction on runs to help understand the variability. Zeke, thank you for sending that in. Clarence, I see your email there. We'll send you the chart that Kevin shared. Roger is saying, we have found that not only machine capabilities for a given process, but the materials must be considered for the application. Carl, thoughts on Roger's statement there?
I agree 100% with what Roger said.
Yeah, Roger that, right?
Roger.
That's right, Roger.
Back to our earlier dad joke. David is saying, just as an FYI, we are working on this function in our software with expected release at FormNet. David, which feature are you referring to there? Just remind us so we can give you a little airtime unless one of the panel remembers.
Oh, that would be Core Technologies. So he's, again, they create some front end software that does some automatic packing. Again, it's another one if anyone's interested in, like, we can connect you with them. Again, we don't resell it, but just kind of class leading type workflow type software. At least I'm assuming that's who it is because I can't see, but I'm assuming that's
okay.
Who it is.
All right. Let us know if we got that right there. From Mark, an idea for another participant here in the room, Clarence, around ideas that might open his mind to other things that can be printed. Mark is saying, we got into this for our bearing covers, but we have since printed some tooling for our CNC. For example, we turned square stock on a lathe. I 3D printed a holder that we can press fit into a PVC pipe sleeve for durability, and extra long shaft ends can safely stick out of the machine on a roller stand. So I think Clarence, Mark has just given you some ideas there around use cases and ideation that might open up new possibilities for you. Mark is saying, I've printed drill templates when something gets missed at our laser to save a part in assembly from being scrapped. I printed drawer organizers for our CNC lathe. Okay, interesting. Thank you, Mark.
Hey,
David is
Can I just build on that, David? Because again,
Yeah.
going back to my passion for what we do, so there's another software out there called Trinkle. We'll do automatic tool design, tooling and fixturing. And again, to get back to it, it's not just about 3D print, but the workflow to get there. And I think that's why it's important to become educated on what's out there and what works. But all of that Mark is doing takes a lot of CAD time. And we talk about automation and workflows. There's a lot out there. So again, if you're ever struggling with a workflow, we probably don't sell the solution, but I can point you in a way to look at that because I'm passionate about the automated thing. Probably use the word passion too much, but
you're passionate about being passionate.
yes, exactly. I'm passionate.
Ryan
squared.
is saying, yes, exactly. Ryan is saying, this is interesting, Ryan. Ryan is saying, I believe this is what stood out to you, Ryan, that you always have to ask, should it be 3D printed? And then, can it be 3D printed? And then finally, how do you 3D print it? Interesting observation there. I see the heads nodding there on the panel. Thank you, folks. If you have any other questions, I want to make sure that you are selfish. I know we're going past our time a little bit here. Thank you to the panel, and thank you to all in the room who are asking these insightful questions. Clarence is saying here, another question from Clarence, in business, productivity is of the utmost importance. What is the fastest good quality 3D printer technology and or brand? Let's go around the table on that. Kevin, I'll start on the right side of the table here, my right. How would you answer that?
I mean, again, self-centered, I would be. Look, I think HP's class leading when you talk production. I give Carbon and some of the photopolymer players credit. I hate to say it, a lot of it's application driven because if you talk metal, it's a different manufacturer. There's great companies out there, Stratasys, 3D Systems. Man, that's a hard one. I mean, we're passionate about HP because we believe the way it can scale, but there are certainly many other technologies that are just incredible.
Middle of the table, Carl, what's your answer?
Yeah, I'm with Kevin on this. Most of our, even our quick turn internal projects are MJF, but sometimes we'll rely on a FDM or SLA or a Carbon DLS machine, which are photopolymer machines. But it's really mission specific and depends on the size, shape, and the requirements for the part. But MJF is a workhorse for us that we rely on.
Our favorite answer of the day so far, it depends, right? I think is kind of the consensus I'm hearing. But Brian, what's your response there to Clarence on his question?
It's really situational. If we have a part that we need to understand the shape and size of it, we may print that out on a Carbon, knowing that the next day we're going to print out 100 of them on the multi-jet fusion, but we're not going to print 100 on Carbon because we're not going to sustain that from the downstream processing. So we shift a lot on the technologies we have based on what the need is.
Clarence, did that help? Let us know if you have any other follow-up questions. I'm going to give you all a second to think if you have any more questions. In the meantime, I'm going to go to you, Carl, first and ask you this question based on kind of the zeitgeist of the conversation today, kind of the gist of the questions that have come in the conversation today. If you could summarize one piece of advice that you would leave everyone in this room with, I'm going to go to you first on this. What would be your one key takeaway based on the questions that you've heard today for the room?
It would be to I think I'm going to take Kevin's, and I think it's to if you're exploring additive manufacturing and it's not a core capability that you have in house, find a trusted partner. That could be a David Tucker who has got Implement AM. It could be a DI Labs. It could be a Kevin Carr, but find somebody who's passionate, to use Kevin's words, about additive manufacturing and its adoption. To gain knowledge and learn from what others have already experienced so that your adoption can be accelerated and be made more successful.
Find a partner. Fantastic. Brian, what about you? Based on the questions that you've heard, the chatter that we've had back and forth with the audience today, the one piece of advice that you'd leave everyone with today?
Keep learning. There is an endless supply of information. And on that journey, if whatever additive is to you, learning is a key part of that. And once you know what you need to know, make a plan.
Keep learning and make a plan. All right. And Kevin, what about you? How would you summarize the top piece of advice?
Well, I think it's about conversations, right? I think it's also about being vulnerable. Yeah, I think the challenge we have in most cases, if we do the reason the work sessions work is we drop our guard down. So I think everyone asking questions, these are questions we want that we generally don't ask to what we consider salespeople or whatever. And I think that's why, whether it be a third party, just be vulnerable, dig into those questions and find people that will trust and will tell you either no or yes. But I think it's about vulnerability in trying to be better.
All right. Well, folks, I'm going to give you another few seconds here. If we haven't answered one of your questions, please make sure that you put that there into the chat. If I missed it, just drop it back into the chat. Kevin, in a moment, I'm going to give you an opportunity to thank the audience and thank the panel for their participation today. But I'm going to wait just another few beats here and see if there are any other questions. I will also ask you, panel, think about this for a moment. Do you have any questions for the audience? Is there anything that you'd like to throw out that they could respond back to you on that would help you or give you some insight that would be helpful to your work? Panel, I see a smile there from Carl. What are you thinking?
I'm trying to read Kevin's face.
Yeah. I got one. You go first.
No, you should. You go.
No, I think my question on any of this is always, what's the best way to start the conversation? And I would love for what do you need, right? We build our businesses based on clients. And a lot of times there are clients, so it's able to do that. But I ask anyone who's on here is like, what do you need? Take us off the table. But around additive and 3D print, if you throw it in the chat or you follow up with it, so that we can figure out how to be better partners or better businesses or better solutionologists. I think that's the one, is we really like conversations and too often they come late. How can we do it earlier? And what value do we need to do it? Does that make sense? Again, I keep asking that. Yeah. See ya.
Yeah.
All right, I'm gone.
You like that, Carl?
I do. Yeah.
Yeah.
My team, can you drop that URL into the chat if folks want to follow up with Kevin on that? Carl, you have a question for the audience, something that you would like to get back from them? Go ahead.
I think Kevin said it best. The thing that I really like about the group that's here at the table is that we are very passionate about solving problems, and we're not in it to sell a part or sell a printer. We're into it to find what the problem is and solve it. So I guess the question is how do we be more effective at opening those doors to help you solve your problems?
I see Clarence saying, I love collaborations. Business is all about collaborating and making new ideas, products, options possible. Yes, Clarence, indeed. Kevin, I'm going to get... Yes,
I got one last one, David. So, last time I offered the gift card, and that was kind of... But I would say this in all reality, and I'm saying this facetiously, but... look, I think most of the times when you converse with us, you're going to have some value. And if you're not, I'll give you the $10 Amazon card. We'll throw that out there again. But yeah, converse with us. Probably gonna maybe sending $10 gift cards to Hong Kong now or wherever.
Exactly. Yeah. What Kevin's referring to is last time he went viral, he made an offer on LinkedIn, I think. He said, hey, you know what? Come to the session. If you don't get out of it what you're looking for, I'll send you a $10 gift card. And I think in the last session, we had like 700, 800 people show up looking for their gift card. So, Kevin, well done. I'm going to give you an opportunity here, Kevin, to not only thank the folks that are to your right and left there, but also the folks here in the virtual room. Go ahead and give thanks, and also any other final words that you want to give to the audience here.
No, I mean, obviously, first, thanks for all of everyone who joined, right? We're busy and we took 90 minutes. So, again, I hope it was informative. And I always say this, give us feedback. If the format's not right, the content isn't right, we do appreciate the time because the questions are invaluable. Obviously, thank you, David, for hosting, and thank you for DI Labs and Brian for stepping in. Again, this is my goal in these things is to bring kind of industry leaders so that people can reach out to us or them. And, I encourage you from that perspective. So thank you. This is a lot of time you guys put in, and it's much appreciated. And again, all for the listeners as well, of course.
Thank you. Thank you. Thank you. All right, everyone. Thank you for your time today. Thank you to the panel, and thank you, Kevin, for hosting this. And of course, to all of you who invested your most precious asset, which is your time. Thank you. Have a great rest of the day, and we will see you on the next event.